Okay, you refer to every object. For some, which is another one, this one, mean there exists some object. Okay, the existence of some object, only for some object. Suppose the domain of the interest is the set of all CPE students in this class. Okay, and we have a relation n of x. This n of x means student x has notebook computer. Suppose n of x means x has notebook computer. For all x, nx would then mean all students in this class have notebook. Actually, we would put s here as well. Okay. For some x, n of x means some students have notebook. Okay. So you can see that with quantifier we can express, we can characterize some sentence which involve quantity. Every quantity, everything or something. There is some relationship between these two quantifiers for all and for some. The right hand side may look complicated. Not for some, not it look complicated, but it means that on the left hand side means everyone have notebook. On the right hand side means it's not true that some students do not have notebook. They are equivalent. Because if you forget this negation for a while, the right hand side sentence means some students. The right hand side means some students do not have notebook. That is the opposite to the left hand side sentence, which say that everyone has notebook. Therefore, if you put negation to the right hand side sentence, you get the same thing.คือมันเท่ากันด้วยประโยชน์ที่ดูซับซ้อนหน่อย not อะไรเงี้ยนะฮะแต่มันคือเท่ากันนะครับคือทางที่จะเข้าใจคือด้านซ้ายมือเนี่ยมันเป็นการพูดถึงทุกนักเรียนทุกคนแต่ด้านขวามือเรามี quantifier ที่บอกว่าบางคนเราจะเขียนอธิบายทุกคนที่มีโน้ตบุ๊กโดยการใช้บอกว่าโดยการใช้ quantifier ที่เป็น for some ได้อย่างไรเราก็ต้องพูดในทางกลับกันแทนที่เราบอกทุกคนมีโน้ตบุ๊กเราก็บอกไม่จริงที่มีคนที่ไม่มีโน้ตบุ๊กคือถ้าคุณปิด negation ข้างนอกมันก็จะบอกว่ามีบางคนที่ไม่มีโน้ตบุ๊กถูกไหมฮะบางคนไม่มีบางคนที่ไม่มีโน้ตบุ๊กมันจะตรงกันข้ามกับทุกคนที่มีโน้ตบุ๊กทันทีแต่ถ้าคุณพุท negation เข้าไปมันก็จะกลับกันมันก็จะเป็นแปลว่าทุกคนมีโน้ตบุ๊กเพราะว่ามีแค่ true กับ false ไงฮะแค่นั้นเองประมาณแค่นั้นเองแต่ไปเรื่อยๆคุณอาจจะค่อยๆเข้าไปเขียนโปรแกรม prolog แล้วคุณอาจจะค่อยซึมเข้าไปคือพวกนี้เรียนลอจิกนี่นะถ้าไม่ได้เขียนโปรแกรม prolog นี่มันไม่เข้าใจเลยฮะมันรู้มันคือจะเรียนไปทำไมแล้วมันอะไรกันเนี่ยถูกไหมนี่อัดเทปไปเลยนะแต่มันเป็นยิ่งจริงแต่มันยิ่งจริงฮะมันเป็นยิ่งจริงคือเราต้องเห็นการใช้งานของมันเลยเนี่ยมีการเขียนใช้งานของมันอะไรอย่างนี้ครับ in the same way we can establish the equivalence between for some and for all in a similar way as well. So on the left hand side you have for some x, some students do not have notebook. That is what it said. On the right hand side it say that it's not true that everyone do not have notebook. Again, you know, the right hand side is just another way of saying the same thing, but we use different quantifier. So these are standard sets. Natural number n. We will use this capital letter to represent different sets. For example, n always mean natural numbers. C means set of integers. C plus the positive one, and so on. We will spend a very brief revision on functions. But the way that I explain function, I would like you to think it a little bit differently. Function normally, it is a mapping from one set to another, from A to B. Normally we call A as domain, B as codomain. But I like you to think function f as a computation. It is a computation in that it takes input A and it produces some output B. Right. The function f itself can be a computation. So it might describe some computation step, some computation formula in f. Also, it can measure some computational step in some algorithm as well. So it depends on our use on f. These are two basic properties of function. The first one, one-to-one, f is one-to-one, and f is on 2. So if we interpret function f as computation, we can see that f is one-to-one if and only if x and y are different, if the input, if the two different input will produce two different output. This is what we mean by one-to-one. I'd like you to take this chance to look at the logical way to describe, to define this one-to-one function as well. We use logic if and only if here to define one-to-one function. Okay. On the right hand side we have logic as well, implication. Okay. We have two logical connective here, if and only if, which is double implication, right? Double implication. This one is implication. So I will later on discuss about this meaning later on. But when f is on 2, we define f is on 2 if and only if for every output B there is an input A such that the input generates the output B by function f. So that means all outputs must be generated from some input. This implies that the amount of input got to be greater than or equal to the amount of output somehow. F bijection if and only if it is both one-to-one and on-2. I'm sure you come across this one-to-one and on-2, but this way of writing down the definition, you may not have seen it before. But this way of writing down definition by using logic is very precise. Okay, you can work out, you can test if f is one-to-one by evaluate the truth value for the two logical connective, if and only if and this implication. We know that the if and only if mean double implication. Then according to the truth table for this implication, for this double implication, we know that whenever the right hand side is true, the left hand side got to be true. Whenever the right hand side is false, then the left hand side is false. So to see if any function is one-to-one, you need to make sure that the right hand side is true when you want to evaluate the function. So then it comes down to the evaluation of this implication. Okay, so you can work out by the truth table to evaluate the truth value for this implication. I like to give some example on one-to-one and on-2 function. Let f be a set of integer, from integer to another set of integer. X squared clearly is not one-to-one because two different input can produce the similar output, the same output. That violates the principle of the definition of one-to-one. On-2 as well, this is not on-2 because with the output -1 there cannot be input which generates such output. However, this is an example of one-to-one, both one-to-one and on-2. Okay, this is a very simple issue on function